is an industrial drafting room. All the plans and information from which finished products are constructed originate here. The ideas developed in the drafting room are expressed in graphic instructions and conveyed to the mechanic or workman by means of drawings or blueprints of drawings. A blueprint is made by exposing to light a chemically treated sensitive paper. It is printed from a tracing in much the same manner as a photograph is printed from a negative. A draftsman produces a tracing using ink on tracing cloth or by using pencil on tracing paper. He may also use a pencil on pencil cloth. Ability to make a drawing depends upon a draftsman's knowledge of what to draw and upon his skill at putting this information on paper. This must be done in such a manner that it will be understood by everyone who must use the blueprints. This can only be done by learning and following established rules which are the accepted practices and by becoming skillful in using drafting equipment. To work accurately and efficiently, the proper tools must be available. First, a board and a T-square. A 45-degree triangle. A 30-degree, 60-degree triangle. An architect's scale for measuring distances. Several drafting pencils. Ordinary pencils are not satisfactory. An F, 2H, and 4H are appropriate for most drafting work. Drafting pencils are obtainable in approximately 20 grades. Notice that 6B is very soft. 9H is extremely hard. The medium hard pencils are the grades most often used by a draftsman. An eraser is necessary, but not this type, nor this, but a soft, clean, ruby red eraser with a beveled edge. An erasing shield is also useful. Thumbtacks or Scotch tape to hold the paper in place. It is extremely important to have a file or sandpaper block to use in keeping pencil points sharp. A set of instruments is essential, although a complete set, such as this, is not always necessary. A sharp knife and a clean cloth are extremely useful. Let's begin work in order to show the proper use of some of this equipment. Before starting any actual drawing, it is important to clean those pieces of equipment which come in contact with the paper. This helps to keep the drawing clean, and the blueprints made from it will then be clear, sharp, and easier to read. A pencil is the draftsman's most important tool. It is absolutely necessary that it be properly sharpened before starting to draw. To identify the grade of the pencil in the future, the wood should always be removed from the end opposite the marking. Never sharpen a pencil over the drawing board. Sharpen it by cutting away the wood at a long slope, being careful not to cut the lead, but exposing it at least 3/8 of an inch. If a draftsman sharpener is available, it can be used, but it must be a special sharpener. Notice the point it produces. Never use a standard mechanical sharpener, as it produces a stubby point which is very unsatisfactory. Whether the wood has been removed by a knife or a special draftsman sharpener, the lead must be sharpened and pointed by using a file or sandpaper block. To keep loose graphite away from the paper, it is wise to attach a string to the block and suspend it from the side of the board or table. A small cloth attached to the string, or formed into a pad and thumbtacked to the back of the block, is helpful in removing loose graphite from the pencil after sharpening. Rolling the pencil between the thumb and forefinger as it is applied to the sandpaper produces a long conical point. The lead should be sharpened frequently. The sander should never be held over the drawing board or placed on any equipment. The point is now a little too sharp. If used, it would tend to groove or cut the paper. The sharp tip can be removed by pressing it firmly and vertically against a very hard surface. A triangle might be used for this purpose if it is cleaned afterwards. Before starting any actual drawing, it is important, that's right, to wash your hands and to repeat this operation frequently. Only your name or your initials are required on a drawing, never your fingerprints. A backing sheet should be placed on the board to provide a smooth and resilient surface on which to work. Detail paper or heavy wrapping paper is satisfactory. It is important to place the drawing paper in correct working position. A right-handed person should place the left edge an inch or two from the left side of the board, and the lower edge should be, if possible, at least a T-square's width from the bottom of the board. A left-handed person should work from the opposite side. If the drawing is to be removed and later replaced, it is wise to locate a small reference mark close to each side of the paper and midway between top and bottom. These marks should be used in realigning the sheet. If shrinkage or expansion occurs in the paper or movement in the head of the T-square, a slight error will then be distributed equally over the entire sheet. Drawings are generally made to fit standard sheet sizes. This is done to simplify filing and to economize in the purchase of paper. Often the sizes of drawings are chosen so that prints from them may be folded to fit a standard filing cabinet. The first lines to be drawn, therefore, are trim lines. These determine the overall size of the sheet. After blueprints are made, they will be cut to this exact size. An edge of the paper should never be used as one of the trim lines. After the overall size of the sheet has been determined, the next step is placing the required border lines. This is followed by drawing the standard title block in its proper place and laying out any other space needed for a bill of materials or an alteration schedule. A drawing is to be made of this simple casting. It is practical to first solve the problem by making a freehand sketch. This should be done rapidly, but in approximate proportions. The sketch should clearly show all of the required views: the top, front, and the right side or profile view. It should contain important overall dimensions. It is not necessary that the sketch be done to any particular scale, but before starting the finished drawing, a suitable scale must be determined. Obviously, 3 views of this casting cannot be drawn full size on the paper. It is not necessary that the drawing be actual size, since there are no small or intricate parts which could not be shown smaller than actual size. It requires judgment to select a suitable scale at which to work. Assuming that 1/2 scale would be appropriate, it is then necessary to determine the correct placement of views in relation to the size of the sheet. The working space provided on this sheet is 9 inches in height and 12 inches in width. The total width which the drawing will occupy will be the length of the front view at 1/2 scale, or 3 inches, plus the depth of the side view at 1/2 scale, or 3 inches. To this is added the distance between views. In this instance, the distance between views is 1 1/2 inches. The total width of the drawing, 7 1/2 inches, is subtracted from the available working space, 12 inches. The remainder is divided by 2. This determines the distance the drawing will be located from each border. In this way, the views are properly located and balanced in the center of the sheet. The calculations are done on the backing sheet, or may be made outside the trim line or on scratch paper. In like manner, the height of the front view and the depth of the top view and the space to be provided between views should be added. This total is subtracted from the vertical working space and the difference divided by 2. The location of the drawing between the top and bottom borders is thus established. The rectangles which enclose the views are blocked in lightly. Within these areas, the 3 views will be completed to develop the finished drawing. Engineering drawing is a language, a graphic language. And just as the English language is recorded by means of an alphabet of letters, Chinese by a group of characters, and music by distinctive marks and notes, so a drawing is made up of an alphabet of lines. Let us consider these lines which are used to describe and dimension a drawing. The visible outline of an object is drawn as a solid, heavy line. Invisible or hidden lines are shown by a series of short dashes. They are approximately 1/8 of an inch long and are separated by spaces approximately 1/32 of an inch. It is a medium weight line, lighter and narrower than the solid line above. A center line is also light, composed of alternating long and short dashes. The longer ones are from 3/4 to 1 1/2 inches. The shorter, approximately 1/8 of an inch, and the space between each dash 1/16 of an inch. A dimension line is light and narrow, with small arrowheads at each end. It is usually broken near the middle for inserting the dimension. The fraction line should be horizontal. Often it can be made at the same time the dimension line is drawn. Extension and leader lines are light. They are the same weight as the dimension line directly above. A cutting plane line is indicated by a long dash followed by 2 short dashes. It is often difficult to find when reading a drawing. Therefore, it should be made heavy to be more noticeable. It is similar in intensity and thickness to the solid line at the top. Adjacent parts or alternate positions of movable parts are sometimes shown on a drawing. These are indicated by medium weight dashes approximately 1/4 of an inch long and separated by spaces 1/32 of an inch. A break line indicates that not all of a view is shown. If extended but a short distance, it may be a freehand line like this. If the break is for a longer distance, the line indicating it should be a light one, drawn partially with the T-square and in part freehand. This is the complete alphabet of lines. Visible, hidden, center, dimension, extension, cutting plane, adjacent part, short break, and long break. It is important that all lines have the correct value or weight, for if drawn properly, they can be the words of a graphic language. Used correctly, they can show this shaft bracket in legible orthographic projection. But if the center lines, the hidden lines, and the dimension lines are not drawn to their proper value or intensity, the drawing looks like this. The shape of the object is difficult to recognize. The drawing is hard to read. Proper contrast of lines is important to clarify any drawing. Order is important in the Army. Order makes an assembly line possible. In fact, doing any job efficiently and economically requires orderly procedure. A house is built step by step. Excavation is the first operation. It is followed by other planned and orderly stages. The masonry, the roofing, the plastering, flooring, and painting. Then, the landscaping. A draftsman, too, does his work in orderly steps. If he were to make a drawing of this furnace hinge to the dimensions shown on the isometric view, a draftsman might first solve the problem by completing a freehand sketch. After the trim and border lines have been placed on the drawing, the views are properly located and blocked in with light construction lines. A medium hard pencil, well sharpened and applied to the paper with very little pressure, produces the desired lines. These light construction lines are easily erased when incorrectly placed or where they are extended beyond their proper length, which frequently occurs while blocking in. After checking the layout carefully, final lines may be drawn. First, the center lines are punched in or drawn to their proper degree of intensity. These lines provide center points for the circles and arcs of circles, which are the next lines to be completed. To draw accurate circular lines with a compass, it is necessary to maintain a well-sharpened lead. A long elliptical face inclined toward the center point of the bow compass should be formed and kept sharp. In setting a compass, the distance should be measured accurately on the backing sheet or on scratch paper, and the compass set correctly to this distance. A trial rotation will determine the accuracy of the setting. Never set a compass directly on the scale. Inaccuracy and damage to the scale will result. Finish drawing all circles, then complete the arcs, which are portions of circles. Horizontal solid lines are the next to be drawn. Starting at the top of the sheet, all of these lines in all views are established. Following these, the vertical visible object lines are drawn, working from left to right. All solid lines are drawn to their correct degree of intensity. Oblique lines are the next to be formed. Invisible object lines are completed from top to bottom in the same orderly sequence as solid lines. The horizontal ones are followed by vertical invisible lines working from left to right. The drawing is now ready to be dimensioned. If the locations of all the dimension lines are indicated by light construction lines, the finished extension lines can next be accurately located. These do not touch the object lines, but start approximately 1/32 of an inch from them and extend to no more than 1/8 of an inch beyond the dimension line. The dimension lines are then drawn over the light construction work. Arrowheads are made and numerals are set in place. Every good draftsman uses guidelines for all notes or directions which are placed on the drawing. This clean-cut drawing has been rapidly completed by applying the alphabet of lines and working in proper order. Draftsmen that develop good fundamental habits of cleanliness, accuracy, and orderliness will rapidly complete drawings to be fed through the blueprint machine.